with Sohcahtoa. Now, none of you, well, I don't know, maybe some of you did have the benefit, but I'm assuming none of you know anything about this. So we are starting at the very, very most basic. So we're going to start with Chief Sohcahtoa, chief of the trigonometry tribe. Now, that's kind of dorky, sure. Sohcahtoa. Remember Sohcahtoa. Now, what does Sohcahtoa stand for? The S stands for sine, which is abbreviated SIN. In math class, when you see SIN, say sine. Don't say sin, people will laugh at you. Say sine. This is the sine. The C stands for cosine. COS is the abbreviation for cosine. The T stands for tangent, and TAN is the abbreviation. So on your calculators, you have buttons that say sine, cosine, and tangent, right? You've seen those buttons. Those are our big three trigonometric functions. Sohcahtoa refers to right triangles only. In chapter 5, we will branch out into some other kinds of triangles, but for the beginning, we're sticking with right triangles. And you remember that a right triangle is a triangle that has a right angle, right? So I'm going to go ahead and label this triangle. I'll call that angle A, and angle B, and angle C. When I look at any right triangle, I have to zero in on one of the non-right angles, one of the acute angles. So I'm just going to look at angle A. This is going to be the focus right now, angle A. With regard to angle A, this side over here is called the opposite side. The opposite side is the side that is across from the angle. If I were looking at angle B, this would be the opposite side. So you got to have an angle to focus on. And once you have your angle, then you know the one across from it is opposite. The one next to it is called adjacent, next to adjacent. And this, of course, is called the hypotenuse. Now, that is a word you've all heard before, and you all know that the hypotenuse is the side that's across from the 90-degree angle. So when I go back to Sohcahtoa, which is going to be important, I mean, we're going to write this at the top of all of our papers probably for a while, Sohcahtoa. I know the S stands for sine. The O and the H stand for opposite and hypotenuse. So sine is opposite over hypotenuse. Guess what the AH, so AH, guess what that stands for? Adjacent over hypotenuse. And TOA, opposite over adjacent. So Sohcahtoa is just a mnemonic device to help you remember the definitions of the functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You have to memorize that, okay? No, you can't survive without it, so we're going to memorize that if we haven't already. Now, what kind of problems are we going to do with that? Well, let's suppose we have our triangle, our right triangle, and the sides are 5, 12, and 13. I'll actually assign some numbers to it now. And I say to you, what is the tangent of angle B? All right, now first of all, you got to look at angle B, right? So here it is. Here's angle B. This is the opposite side, right, for angle B. This is the adjacent side, and this, of course, is the hypotenuse. We want the tangent of that angle. Tangent, TOA, opposite over adjacent. So the answer to the problem would very simply be 5 over 12. easy. So, okay, what's the sine of angle B? Well, the sine of angle B, what's sine? So, opposite over hypotenuse. So the sine would be 5 over 13. Okay? Now, while I'm putting down some attendance, I'm going to give you another one. I'd like you to do a couple more. I'm going to erase this, but it's on your sheet, so you've got it. I'm going to draw my triangle a little bit differently. That does not change anything. Okay, so there's our triangle. While I'm taking attendance, I want you to find the sine of angle A and the cosine of angle C. Now watch it, because I got different angles going here. So you have to pay attention. See if you can do those two for me while I get my attendance figured out. So I'm missing Ellie. Avery, Kelly, Beachy, Cameron, Julie, Mason. Eric, Clayton, Tony, Lucas, Meredith. No Meredith. Philip, Caroline, no Trey. Where is everyone today? Megan, Kian, Desiree, Finn, Marissa, Tag, Luke, Daniel, Bryn, Jonathan, Alex, no Jay. This is a wild and crazy problem. What did you get for the sine of angle A? Who said 3 over 5? You're right, Bryn. It's 3 over 5. Why is the sine of angle A 3 over 5? Because here's angle A. What's sine? Opposite over hypotenuse. Now, what about the cosine of C? The cosine of C is also 3 over 5. Because now I'm looking at angle C. Cosine is adjacent over hypotenuse. So I got the same number for both of those problems. You okay with that? All right, so that's the first thing we got to have memorized, is this whole notion of Sohcahtoa, what's opposite, what's adjacent, and all that stuff. All right, the next thing we have to, or another thing that we have to have memorized, is the idea of the special right triangles. Now, when I say special right triangles, what I'm talking about are 45, 45, 90. Now, I don't expect you to remember that from when you learned it back in geometry 2 years ago, but 45, 45, 90 should sound familiar to you. Yes, there are triangles that are called 45, 45, 90. There are another set of special right triangles that are what? 30, 60, 90. Yep, there we go. Those are our special right triangles. You need to memorize, and again, at the beginning here, it's like a brand new language. We got to learn the language, got to learn the definitions. You need to memorize that in a 45, 45, 90, across from the 45s will be 1s, and the hypotenuse is root 2. That isn't going to change. Every 45, 45, 90 triangle you draw in trigonometry land will be 1, 1, root 2. Okay, period. We're going to memorize that. Now, for 30, 60, 90s, same thing, different numbers. Across from the 30 is a 1, across from the 60 is a root 3, and the hypotenuse is 2. Now, you're thinking to yourself, oh my gosh, she's crazy if she thinks I'm going to memorize all this. You have to memorize it all, kids. We don't have a choice. It's the only way to do the subject. So what kind of problems are we going to use that for? Well, suppose I said to you, what is the tangent of 45 degrees? All right, got to combine our two ideas. So Sohcahtoa. So tangent is opposite over adjacent. Here's your 45-degree angle. What would be the opposite side? 1. What's the adjacent side? 1. So the tangent of 45 is 1 over 1, which is 1. Now, last period, somebody said, well, Mrs. Ford, what if you use that 45? I could use that 45. What's the opposite side? Adjacent side.
1.
Does it matter which 45 I use? No. No. They both give the same answer. How about this? What is the cosine of 60 degrees? All right, so now we're doing cosine. Here's the 60. What's cosine? Adjacent over hypotenuse. Here's your 60.
1 over 2.
Adjacent over hypotenuse would be 1 over 2. All right? And then there's one more thing, one more big thing that you have to memorize. We've got these main functions, sine, cosine, and tangent. But there are actually 3 more trigonometric functions. There are 6 altogether. These are the big 3. They're the ones we use the most because they're on our calculator. The other ones are not on our calculator, and we'll have to talk about how we're going to deal with that later. What are the other 3 functions? They are the cosecant, the secant, and the cotangent. And I have not randomly placed those. I have lined them up in order for a reason. These are reciprocals of each other. They are reciprocals of each other. So what does it mean to be a reciprocal? What's the reciprocal of 2/3? 3 halves. So if sine, remember Sohcahtoa, if sine is opposite over hypotenuse, then its reciprocal will be what? What's the reciprocal? Hypotenuse over opposite. Cosine, think Sohcahtoa, adjacent over hypotenuse. So its reciprocal will be hypotenuse over adjacent. And tangent, Sohcahtoa, opposite over adjacent. So its reciprocal will be adjacent over opposite. All right, couple of things about this. First of all, Mrs. Ford doesn't even have these memorized. Okay, what I have memorized is sine is opposite over hypotenuse, Sohcahtoa. I have that memorized. Then I remember that the cosecant is its reciprocal, so therefore it must be hypotenuse over opposite. I remember these reciprocal relationships. Now, you're thinking, oh, I'm going to get this all confused. No, you won't if you're careful. Notice that in each pair, there's exactly one co. The co's are never paired up. So the reciprocal of the cosine has to be the secant, because you can't pair it up with anything else. Co's don't go together. Okay? So hopefully that will help you a little bit. Now, abbreviations, we don't write these words out all the time. We use abbreviations. Cosecant, CSC, secant, SEC, cotangent, COT. Those are the abbreviations. All right, so what's a problem like that going to look like? Well, let me draw my triangle again. And suppose I said, let's find the cotangent of angle C. Now, you can do this however you want. I will do it this way. I'll say first I'm going to find the tangent of angle C. Because I know tangent is what? Opposite over adjacent. So here's angle C. What will opposite over adjacent be? Opposite over adjacent. 3/4. If the tangent is 3/4, its reciprocal will be 4/3. Does that make sense to you? I know it's a lot. That's why I wanted you to do this over break. Get this memorized over break. Let's try another one here. What's the secant of angle A? Well, the way I'll do it is, I won't do secant, I'll do cosine. What's cosine of angle A? Adjacent over hypotenuse. Good. So the cosine of A is 3/5. Here's A. Adjacent over hypotenuse, 3/5. If the cosine is 3/5, then the secant is 5/3 because they are reciprocals of each other. All right? Now look at your gold sheet. We talked about everything on the gold sheet but one thing. Can you see what it is? What have I not talked
Circle.
about? Well, the whole circle thing with the X, Y, and R. Now, those are definitions, alternative definitions for sine, cosine, and tangent that you're going to need to know, but not immediately. These things that we talked about today are the things we have to know just to get the ball rolling. The rest of them you are going to need in this chapter, but it'll be a little bit later before we need those. Okay? All right, I'm going to give you 2 problems. You can go when you bring me the right answer. All right? I think. I can let you go. Yeah.
Let you go. Let me get the right answer.
Yep, you got to write them down somewhere. And then you are allowed to use your gold sheet if you need it. If you already got this stuff